Hey everyone, welcome. Today we're going to dive into a really important and honestly often misunderstood part of Kubernetes, quality of service. And we're going to focus on the riskiest one of all, the best effort class.
So let me ask you something. Have you ever had this happen? You're working on your Kubernetes cluster. Everything seems totally fine. And then, poof, a pod is just gone, right? No error, no failed deployment. It just vanishes. It's so frustrating.
But here's the twist. What if I told you that's not a bug? I mean, not at all. That whole disappearing act, that's actually Kubernetes working exactly the way it's supposed to. And that is the mystery we're going to solve right now.
Okay, so Section 1, the case of the missing pods. Let's dig in and figure out the why behind this whole thing. You see, the secret is all about a hidden priority system inside Kubernetes. It's kind of like a built-in rule book. And the number one rule? Keep the system stable, no matter what. Even if that means, well, sacrificing a few workloads along the way. It's this hidden hierarchy that decides which of your pods are VIPs and which ones are, let's just say, expendable.
And this brings us to Section 2, Kubernetes Hidden Class System. So this whole hierarchy is managed by something called Quality of Service Classes, or QoS for short. You can really think of it as a secret class system that decides the fate of every single one of your pods.
Okay, so check this out. Kubernetes automatically slots every single pod you create into one of three buckets. At the top, you've got guaranteed. These are your VIPs, super safe. In the middle, there's burstable, kind of the middle class. And then way down at the bottom, with the absolute highest risk of getting the boot, you have best effort.
So let's zoom in on that last one. This is Section 3, the best effort bargain. Because you know what? Understanding this class is the key to solving our whole missing pod mystery.
So you might be wondering, how does my pod end up in this low priority, high risk group? Do you have to set some special flag? The answer? Well, it's actually way simpler than you'd think.
See, the secret isn't about what you put in your pod's configuration file, it's about what you leave out. If you crack open the pod's YAML, you'll see there's no resources block at all. Nothing. No CPU or memory requests, no limits, zip. It's that complete absence of information that dumps the pod straight into the best effort class.
So that's the hard and fast rule right there. If you don't tell Kubernetes anything, and I mean anything, about the resources your pod needs, no requests, no limits, it just automatically slaps the best effort label on it. It's like you're telling Kubernetes, I don't really have any specific needs, just do whatever.
And I think this next part just sums it up perfectly. It's like you're making a deal with Kubernetes. You're saying, hey, let my pod use whatever spare CPU and memory you've got lying around. And Kubernetes says back, sure, you can use whatever's free, but we make absolutely no promises. No promises about its survival at all.
And that right there, that no promises part, that's where things get dangerous. Because what happens when the system gets stressed out and has to make a tough choice? Well, that brings us to Section 4, first on the chopping block.
So in the world of Kubernetes, when a server, what we call a node, starts running low on resources like memory, it goes into the state called node pressure. Think of it like the node is struggling to breathe. And when that happens, the system has to step in and make some really tough calls to stay healthy. It needs to free up resources, and it's got to do it fast.
So how does it decide which pods to kill? It looks at their quality of service class. And this makes it super clear. When the eviction process starts, and yeah, that's just a polite way of saying killing pods, the guaranteed pods are totally safe. The burstable pods, they're at risk. But the best effort pods, oh man, they're in a league of their own when it comes to risk.
In fact, it's not even a question of high risk. When the system needs to start clearing house, they are guaranteed to be number one, the very first in line to get kicked out.
And here it is. This is the crucial takeaway, the solution to our whole mystery. When a node is under pressure, the kubelet, the brain on that node, will always kill the best effort pods first. Always. So your pod didn't just vanish because of some weird bug. It was evicted. It was kicked out because it was the lowest priority citizen on the block.
Okay, so now that we know just how risky this is, it begs the question, when, if ever, should you actually use it? Let's talk about that in Section 5, Use Cases and Warnings.
All right, let me be crystal clear here. Do not use best effort in production. Just don't. Why? Because its performance is a total crapshoot, you get zero guarantees about where it'll run, and like we've just seen, it's the first thing to die when the going gets tough.
It is just way too risky for anything you actually care about.
But that doesn't mean it's totally useless. There are a few places where it's actually okay. If you're just playing around in a lab or a learning environment, great. Need to spin up a quick temporary pod to debug something? Perfect. Or maybe you have some totally non-critical task that you genuinely don't mind if it gets killed and restarted. Yeah, go for it.
So let's just run through that whole chain of events one last time super quick. 1. You create a pod and give it 0 resource requests or limits. 2. Because of that, Kubernetes slaps it with the best effort QoS class. 3. That immediately makes it the lowest priority pod on its node. And 4. The second that node feels any pressure, your pod is the absolute first one to go. And just like that, mystery solved.
And that really leaves us with one last big question to think about. Okay, so now you know how your pods get prioritized. But what if your nodes are the ones that are constantly running out of gas? Solving that problem, well, that's the whole other half of the battle. Thanks so much for watching.